Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Let's see the problem. Prove that given an acute triangle, so here I show as ABC, construct circles with each of its sides as diameters. Draw tangents on 3 circles from opposite vertices. So in this figure, I draw the circle with a diameter BC and draw the tangents from the opposite vertex A. Right. So prove that 6 tangency points lie on the common circle. Basically, we want to prove that there is a point on this plane, right? There is a point on this plane has an equal distance for these 6 tangency points. Consider the symmetrical of this figure. So we basically can just say that if we can find a point, right? If we can find a point that has an equal distance to P and Q, and the formation of this distance is totally symmetrical regarding to AB, AC, and BC, which means they can, if we change AB to BC, BC to CA, CA to AB, then the equation still be the same, right? If that is true, then we just prove it. Okay, since we are talking about the centroid, of course you can guess that the center of this common circle is on the centroid, right? Let's just assume, just do a calculation of the centroid. So the first thing that we can do is that we connect PM and MQ. And we already know that M is the center of this circle. And also M is the midpoint of BC. And we know that M, because AP, AQ are the tangent line of the circle M. So MP is perpendicular with AP and MQ is perpendicular with AQ, right? So now the question is how can we calculate? So here is G. How can we calculate PG? Notice that MP equals 2, MQ equals 2, half of BC. Right, so we can calculate PG squared, which of course equals to GQ squared, right? Because of the symmetric, then we can calculate PG squared equals 2 MP squared times AG to AM plus AP squared times MG to AM minus MG times GA, right? Or it can be written as equals to, so MP squared times AG to AM, that is 223, plus AP squared times MG to AM, that is 123, minus MG times GA, so it equals to, we can rewrite it as MG times GA to AM squared times AM squared, right? And we know that MG to AM, that is 123, and AG to AM, that is 223. So total is 229 times AM squared. AM squared can be calculated as AB squared actually half of AB squared plus AC squared minus quarter of BC squared, right? And we know that MP equals to half of BC, so MP squared, that is quarter of BC squared times 223 plus AP squared. AP squared can be written as AM squared minus AM squared minus MP squared, right? Times 123 minus 229. We have squared plus AC squared minus 12BC squared, right? That is a whole term, and we can still expand this AM squared. AM, let's just write it down here. So this one, make it to be 126 BC squared. See, MP squared, that's 124 BC squared times 1/3, right? So minus 1212 BC squared plus 1/3 of AM squared, right? So let's actually write it here. Would be plus 1/3 of AM squared minus 229 AM squared, right? So it equals to 1212 BC squared plus 129 AM squared, right? AM squared is 122 AB squared plus AC squared minus 124 BC squared, right? So it equals to 1212 BC squared plus 1218 AB squared plus AC squared minus 1236 BC squared, right? And this equals to 1218 AB squared plus AC squared. See, the 1 to 12, that is 3 to 36, minus 1 to 36, that's 2 to 36, which is 1 to 18, right? So that's 1 to 18 plus BC squared. Okay, now we know that if we do it from point C or point B, we would get the same equation of the tangent point to the centroid, right? So that's a way we just prove it. And of course, we can have an assumption to find this point, right? Like we don't know whether it's a centroid on any other point, but we can be sure that because triangle APM is congruent to triangle AQM, so if this point exists, it must be on AM, right? It must be on AM. Similarly, this point should have the same distance to the tangent point from B, which means that point also on the that point is also on the median from B to AC, right? And that means the point can only be the centroid, right? But still, we can do the calculation. We can assume that AG to MG equals to K, right? Let's say this point is H, right? AH to HM equals to K, and then we force AB, AC, BC to have the same parameter here. Then we can solve for the K, and eventually we know that AG to AM is 223. So G means centroid is a point we're looking for. Anyway, this just shows how we do the calculation and how we find the distance to prove this. Okay, I hope you like this video. See you in next one. Thank you.